So we started with a square wave that had a period of 2 pi. Then we said, can we represent it as an infinite series of weighted sines and cosines? And then working from that idea, we were actually able to find expressions for the coefficients, for a sub 0 and a sub n when n does not equal to 0, and the b sub n's. And evaluating it for this particular square wave, we were able to get that a sub n is going to be equal, or a sub 0 is going to be 3/2. That a sub n is going to be equal to 0 for any n other than 0. And that b sub n is going to be equal to 0 if n is even, and 6 over n pi if n is odd. So one way to think about it, you're going to get your a sub 0. You're not going to have any of the cosine terms, and you're only going to have the odd sine terms. And if you think about it just visually, if you look at the square wave, it makes sense that you're going to have the sines and not the cosines, because a sine function is going to look something like this. So a sine function is going to look something like this, while a cosine function looks something like, let me make it a little bit neater. A cosine function would look something like that. And so cosine and multiples of cosine of x, so cosine of 2x, cosine of 3x, is going to be out of phase, while the sine of x, or I should say cosine of t's, and the sines of t's, sine 2t, sine 3t, is going to be more in phase with the way this function just happened to be. So it made sense that our a sub n's were all 0 for n not equaling 0. And so based on what we found for our a sub 0 and our a sub n's and our b sub n's, we could expand out this actual, and we did in the previous video, what does this Fourier series actually look like? So 3/2 plus 6 over pi sine of t plus 6 over 3 pi sine of 3t plus 6 over 5 pi sine of 5t, and so on and so forth. And so a lot of you might be curious, what does this actually look like? And so I actually you can type these things into Google and it will just graph it for you. And so this right over here is just the first two terms. This is 3/2 plus 6 over pi sine of t. And notice it's starting to look right, because our square wave looks something like, it looks something like this, where, so it's going to go like that, and then it's going to go down to 0, and then it's going to go, and it's going to go up. It looks something like that. It doesn't have the pi's and the 2 pi's marked off cleanly, but it's going to look something like that. So even just the 2 terms, it's kind of a decent approximation for even 2 terms. But then as soon as you get to 3 terms, if you add the 6 over 3 pi sine of 3t to the first 2 terms, so if you look at these first 3 terms, now it's looking a lot more like a square wave. And then if you add the next term, well, it looks like even more like a square wave. And then if you add to that, to what we already wrote down here, if you were to add to that 6 over 7 pi times sine of 7t, it looks even more like a square wave. So this is pretty neat. You can visually see that we were actually able to do it. And it all kind of just fell out from the mathematics.